Okay, so let's start this very first problem here. The question states that the value of a crop per hectare is defined by the v variable, and it's a function of the number of days d. And this is the main equation they give you. And after that, they give you some numbers here. So here, here, and they also give you some other numbers over here and here. Now, just by reading this problem, I have a feeling that this 225 is kind of like a y value, and this 50 days is kind of like an x value, and this $240 is another y value, and this 60 days is another x value. And then you're going to create two equations with two unknowns and solve for the missing variables. Okay, so that's my general thoughts just by kind of reading the initial question, but let's go ahead and take a look at this problem here in details here. So just remember your v variable is measured in dollars, right? So this is kind of like measured in dollars. M is what we're trying to find, and d is measured in days. And this 2 is just a 2, and this b is also something that we need to find, right? So in this problem, you got to find the values of m and b. Okay, great. So let's go ahead and just insert the numbers into let's go ahead and insert these numbers into the formula, and then let's get started here. So v represents dollars. So if I continue this off, my first equation should be 225 equals to m squared, which is what I'm trying to find. And then you have a d variable here, which represents your days. Well, you have 50 days, right? So that's going to be a 50, close bracket, plus 2 times b. So that's your very first equation right there. And then from that, we're done with the information there. And now we need to use the $240 per hectare after 60 days. Okay, so once again, okay, we're done with this stuff. And v is measured in dollars. So that's going to be 240 equals to m squared, which is the variable that I need to find. And now we have 60 days. So that's going to be 60 plus 2b. So there you go. There are your two equations, and you have two unknowns. The two unknowns are your m's and the b's. So this is now a very traditional problem now. Now what I would do is I would just kind of clean this up. So this would be 240 equals 2. Okay, so 60 times m squared, if I multiply that out, that's going to be 60m squared plus 2b. And then after that, let's go ahead and clean up this very first equation here. That's going to be 225 equals 2. Well, 50 times m squared is 50m squared plus 2b. Okay, great. So now we're in a pretty good situation. Notice that these two, this is equation number 1 now, and this is equation number 2. What I notice right now is this part right here, the tail ends here, the 2b's and 2b's, they're exactly the same, and that's great because now I can get rid of the b's by subtracting equation 1 from equation number 2. So this is a very similar technique that you probably used in grade 10 math, where I'm going to take equation number 1 and subtract it from equation number 2, and that way I can eliminate one of the b variables. Okay, so if I continue here, ask yourself, what's 240 minus 225? Well, that's going to be 15 equals 2. And then ask yourself, what is 60 minus 50? Well, 60 minus 50 is 10. And then the m squared variable remains. And then this is where Alexa might have some problems here. But if you have 2 bananas, so 2 bananas, and you lose 2 bananas, that's going to be 0 bananas. Okay, so from here on, now you can divide both sides by 10. 15 divided by 10 is 1.5. The 10's cancel, and this gives you an m squared. And in order to solve for m, you can now square root both sides. And if you square root both sides, you do have the plus or minus root 1.5. So those are your possible m values. And then what you would do next is you would go back to the original equations, and then you would go ahead and solve for the missing b variable. Now, if I go ahead and use this equation right here, I have 240 equals to 60 times m squared plus 2b. What you're really doing is you're taking the plus or minus root 1.5 and you're plugging it in for that m value right there. Now, the good thing here is it doesn't matter if you have plus or minus, because if I plug in the m here, so what I mean is it plus or minus root 1.5? what I'm trying to say now is this plus or minus thing, it really doesn't matter because when you square it, you always get a positive result, right? So positive 1.5 squared gives you a positive result. Negative root 1.5 squared gives you a positive result. So I can just get rid of that because I know the final answer will be positive. So now this will be 240 times, or equals to 60 times, well, root 1.5 squared is going to be just, well, this whole thing right here is just going to be 1.5, and you can verify that with your calculator, plus 2b. And then just do this calculation here, 60 times 1.5. That's going to be 90. Equals to 240, and then I have my 2 plus 2b at the very end. And then you can just subtract 90 from both sides, giving you 2b on the right hand side. So 240 minus 90 is 150. And then we can divide both sides by 2. And b would equal to 150 divided by 2, which is 75. All right, so the values of m that work are plus root 1.5 and 75. So that's m, and that's b. And we also have negative root 1.5, and we also get 75 as a final answer for that particular case as well. Okay, so I hope that's enough feedback to get you started on that particular question. I think the other question that you sent me was a little bit more work, was this graphing question, and I find that this question is a little bit more challenging just because the numbers are pretty ugly here. Well, basically, you need to graph these two functions here, and one of the problems I have with this particular problem is that the numbers are kind of ugly, especially on this quadratic function. And I don't know if you are allowed to use a calculator or not, but I do find that since the numbers don't work out very nicely, maybe you can use a scientific calculator and graph that. But let me just grab out some notes here, and I'll try my very best to show you the main steps in graphing that. So if you have a quadratic, let me just move this over here. Let's just say you have a quadratic, so negative 16x squared plus 177x plus 4. Now the very first thing I would do is find your y-intercept. Now the y-intercept happens when x is 0, and then if this is 0, then all these go away and you're left with plus 4. So my y-intercept is 0, 4, which is nice. And let me just erase that. Then after that, I would go ahead and find the vertex. Now, I don't want to spend a lot of time doing the completing the square technique, so let's go ahead and use the vertex formula. So if you want to find the x value, it's going to be negative b over 2a. The b value here is 177, and the a value here is negative 16. So if I want to find the x value of the vertex, it would be negative bracket 177 divided by 2 times a, which is negative 16. And you do have to work out the math on that. And if you go to your calculator and plug that in, you should get a positive number because there's 2 negative signs. So if you go to your calculator and do that, you get 5.53125. And because of that number, that's my reasoning why I do think students probably need a calculator to find the vertex. And then let's go ahead and find the y value. Well, the y value, the formula that you can use is c minus b squared over 4a. And now the c value is 4. So if I go ahead and plug the numbers in, it'd be 4 minus bracket. The value of b is 177 squared divided by 4 times a, which is negative 16, I believe. And you'll notice that this minus sign and that minus sign, that's going to give you a result of 4 plus. Hold on, and 177 squared, that gives you an answer of 31,329 divided by, and 4 times 16 is going to be 64. And if you actually go to your calculator and do that, I get 493.515. So once again, these are pretty ugly numbers for the vertex. And I'll summarize the results at the very end, but because those results are kind of ugly, that makes me believe that you do need a calculator to do this problem, but make sure you ask your teacher if that's the case or not. Now, when you have a parabola, I know the parabola is probably going to look like something like that. So the good thing is we have the y-intercept, we have the vertex, which is right there. I would go ahead and also find the x-intercept right there. And if you want to find the x-intercept right there, I would go ahead and use the quadratic formula. Okay, so let's go ahead and do that. I'm going to go ahead and erase all this stuff now. And what we're going to do now is we're going to try to find the x-intercepts. So right away you can probably use the quadratic formula here. So x equals to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so if you want to factor this, maybe it's factorable, but I just didn't really double check. I'm just going to jump right to the quadratic formula here. So negative b, so negative 177 plus or minus the square root of 177 squared minus 4 times negative 16 times 4 all over 2 times negative 16. And let me just kind of skip some steps here just because I do feel like students are pretty good at finding the numbers here. And if I do this, hold on, this is negative 177 plus or minus the square root of 31585 divided by negative 32. Okay, so when you go ahead and compute this, the only answer that gives you, remember the x-axis is time, right? So you want a positive x value here. So what you should do is right here when it says plus or minus, you should just really change that to a minus because that will give you a positive answer, right? So if you go ahead and compute that, you should get 11.085. So that is your that's one of your x values. I mean, you do get another x-intercept, but that other x-intercept is like way over here in the negative range, and you don't really care about that. And 11.085 is a better number to have for this particular problem. Okay, so that's my recommendation in terms of finding the key points to graph the parabola. Now let's go ahead and just graph all of this. We know that the y-intercept at the beginning, we concluded that the y-intercept was 0, 4 for the parabola. So 0, 4 is probably way down here. And we also concluded that the vertex, let me just find my notes here again. The vertex was 5.53 and the y value is 493.515. So let's go ahead and plot those points on the graph here. 5.53, where's that? So here's 5. So 5.53 somewhere there, and 400 is very close to there. So something around that point. This is my vertex. Okay, so 5.53, and the y value is 493.515. And we also just found the x-intercept, right? So the x-intercept, I kind of skipped a few steps there because I know you can find the y-intercept on your or the x-intercept on your own. I had 11.085, and that's somewhere around here, I guess. This is 11, so maybe somewhere around here. This is the x-intercept. Okay, so based on that, you would do your best and connect the graph and something like that, approximately something like that. I'm hoping that this is a calculator question because the numbers here are pretty difficult to work with. Okay, that's it with the quadratic formula. Okay, now let's analyze the linear function that's given to you for the second part of this problem. And the linear function is y equals to 65x plus 100. So we're going to graph that linear equation, and we're going to try our best to find the x-intercepts because the question is asking determine the points of intersection and explain what they mean. Okay, so basically all you're doing is if you graph this linear function here, we know the y-intercept is going to be 0, 100 because of that 100 right there. So if I put my y-intercept over here at 100, I mean, it's a linear line, so the graph is going to look like that. What we need to do is we've got to find these intersection points. All right, so this graph is a rough estimation. I'm going to clean it up at the very end once I find those exact points. But in order to find these points right here, we have to use some algebra work. And what we need to do is we need to take the original quadratic that was given to us, this purple function here, and we have to make it equal to this linear function. If we do that, then we can find those two x values, which are right here. And if I know the x values, we can always find the y values right after. So now the rest of the problem, you have to do a little bit of algebra work. Okay, so the algebra work isn't too bad. I just feel like it's just a lot of like work that may take quite a bit of time. So let's go ahead and do the algebra work right now. Okay, so let me just erase all this. Okay, so one of our equations, let me just rewrite the linear equation. The linear equation was 65x plus 100, and the quadratic was y equals to negative 16x squared plus 177x plus 4. Okay, so once we do that, what we can do is we can make these two functions equal to each other. And if you do that, we would now get 65x plus 100 equals to negative 16x squared plus 177x plus 4. Okay, so what I would probably do next is I would just take my 65x and bring that to the other side, and I would also bring my 100 and bring that to the other side, and then simplify. So if I do that, I would get negative 16x squared. Now if I take 177x and if I subtract 65x from that, I would get positive 112x. And if I take my 4 and if I subtract 100, I would get negative 96. And then that would all equal to 0. And then after that, we just need to solve this. Now, I don't recommend using the quadratic formula here, because if I take a look at the negative 16, the 112, and the 96, I can factor out a negative 116 because that's a common factor. So let's factor out the negative 16, and then I would get x squared minus 7x plus 6. So those are things that you should be able to do. And then the good thing here is now you can factor this trinomial using some grade 9 math. And now you would have x here, x there. We need two numbers that multiply to 6 and add to negative 7. So that would be negative 6 and negative 1. And that's really nice because now you can take this part right here, and that would be x equals to 6, and that would be x equals to 1. All right, so that's where the graph would intersect. Okay, so we have to now find the corresponding y values, and I would recommend going back to your linear equation. And your linear equation, I believe, was 65x plus 100. So I'm just doing this really, I'm not really doing a great job explaining this. I'm just trying to rush this now. You plug the 1 in there, you get y equals to 65 times 1 plus 100, which equals to 165. So this point right here is 1 comma 165. All right, erase all that. And then we take the 6 here. Whoops. We take this 6 right here, and then we plug that in over there. And I get y equals to 65 times 6 plus 100. And if you do the math there with a calculator, what is this now? This is going to be 490, I believe. 490. So that implies that this other intersection point is 6 comma 490. Okay, that was a bit of work right there, but now we have to go out there and explain what these two intersection points mean on the graph, right? Okay, so let's go back to the graph here, and I'll try to do this very slowly here. Just erase all this, because those are all just estimations there. Okay, I'll just blow this up here. Okay, so if the graph did go through this intersection point, sorry, the intersection points are at 1. So the points were 1 and 165, and the other one was 6 and 490. Okay, so at 1 and 165, so this point right here, and the other point is 6 comma 490. Okay, so if I go ahead and just plot that linear line there, this intersection point would be 6 comma 490, and this intersection point right here would be 1 comma 165, I believe. Okay, great. So those are the intersection points. And then finally, the question is, we have to explain what these points mean. And now, if you read the problem, I believe there was a rocket that was being launched, right? So the rocket is being launched. This is the path of the rocket. So the rocket goes all the way up to a max height and then comes back down. Okay, so this intersection point means after 1 second, the rocket is in the boy's line of sight, I believe. So I believe it says line of sight. So what that means is when this boy is on the 10th floor of the building, after 1 second, he can see the rocket, and the rocket has a height of 165 feet. And then 6 seconds later, the rocket falls down to a point where the boy can see the rocket again. So after 6 seconds, the boy can see the rocket falling down, and the rocket is at a height of 490 feet. So those are what the points mean in this particular problem. Okay, so I do apologize that I was a bit fast in this video, but on a Sunday, I really don't want to be making math videos, but hopefully some of this makes a little bit of sense. And if you need more help, just ask your teacher, okay?